E is not just a tool we use to simplify mathematics, it has its own free will. Let's do an exercise and figure out which is greater, e to the power n or n to the power e. Let's start by taking log on both sides, then we get n versus e times log n. Now we'll use a brilliant idea and consider n to be equal to e to the power k, which eliminates the log, and we will get e to the power k versus e times k, which is a condition for exponential versus linear. We can see that except when k is equal to 1, e to the power k is strictly greater than e times k, so e to the power k is greater or equal to e times k, which you can see through the graph. E can come up randomly. Let's see this infinite power tower for an example. Here, we're trying to find when it converges. Through algebraic manipulation, we get that f of y is equal to y, which is the concept of a fixed point. To fixed point convergence criteria, we know that the absolute value of the derivative of the function should be less than 1. So let's keep the function in the equation, and through algebra we get that absolute value of log of x to the power y is less than 1. Since x to the power y is equal to y, absolute value of log y should be less than 1. So y lies between e to the power negative 1 and e, a sudden appearance of e. For x again, we find that it lies between e to the power negative e and e to the power 1 by e. Here we can see the additive inverse and multiplicative inverse in play. Now an interesting exercise. Let's cut a number into equal parts and then let's multiply them. Let's take number 10 for an example. What we find is when the number we get after cutting it is closest to e, the product is the maximum. This happens because, stay tuned.